students. In this video, we are going to explain about a project titled Probabilistic and Deterministic Wind Speed Prediction and Ensemble Statistical Deep Regression Network. The challenges brought by inherent intermittency of wind power and the operation of power system. To tackle this, an emphasis is placed on precise forecasting and comprehensive wind speed information provision in advance. This approach seeks to mitigate the power system instability due to unpredictable wind fluctuation. This study goes behind the research by identifying the various unresolved issues. These include the absence of an effective structure for accurate wind speed prediction from the raw data and the inability to furnish the precise statistical information without the prior knowledge of distribution function and the capacity to grasp the uncertainty pattern and the spatio-temporal characteristics. The objective is to establish a novel probabilistic technique for the wind speed prediction. This approach combines the advanced deep network with the non-parametric probability density function estimators, introduced an innovative strategy for addressing the wind power intermittency challenges. Mitigating the uncertainties associated with the wind speed variability and the wind energy is vital due to its impact on the power system operation. To tackle this issue, we introduce an innovative solution involving an ensemble residual regression deep network. This network aims to provide an all-encompassing forecast of wind speed characteristics. In addition, we put forth of a novel approach that involves a refined error-based loss function and an enhanced kernel density estimator. These modifications are designed to bolster the accuracy and dependability of our probabilistic wind speed forecasting method by conducting the simulations and the comparative analysis using the real-world data from London. We substantiate the effectiveness of our proposed technique in addressing these challenges and highlight its promising capabilities. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the package. Essential libraries and packages are imported to facilitate the data manipulation, analysis, and model building for wind speed prediction. And the second step is exploring the dataset. The wind speed dataset is explored to understand its structure, variable, and the potential trend. And the third step is data processing. Raw wind speed data is cleaned, processed, and transformed as necessary. This involving of handling the missing value, outlier treatment, and data normalization. And the next step is visualization using Seabird and the Matplotlib. Data visualization tools are used to create the visual representation of the wind speed data. And the next one is feature selection. Relevant features that influence the wind speed prediction are selected. This step enhances the model accuracy by focusing on important variables. And the next step is reshaping the data. The data is reshaped and prepared in a suitable format for training and the testing of the wind speed prediction model. And the next step is building the model. Various models are built. The first one is SVR. Support vector regression is a machine learning algorithm used for regression tasks. It aims to find the hyperplane that best fits the data while minimizing the margin of error. In this project, SVR be employed for the wind speed prediction where the historical data and relevant features are used to predict the wind speed. And SVR learns the relationship between the features and the wind speed, allowing it to make the accurate prediction for the. And the next one is voting classifier. Voting classifier combine the predictions of the multiple individual classifiers which can be different of algorithms are combined. In wind speed prediction, the ensemble approach can enhance the prediction accuracy by leveraging the strength of linear regression, random forest, K-near slider. And the next one is stacking regressive. It is an ensemble technique where multiple regression models are combined to improve the prediction accuracy. For this project, it leverages the prediction of linear regression and a support vector mission combined with the random forest to optimize the final prediction. And the next one is ResNet. ResNet is a deep neural network architecture that uses the residual block to allow for training the deep network without vanishing the gradient issue. And in this context of this project, ResNet can be used to capture the complex relationship between the meteorological feature and the wind speed. And the next one is GRU. Stands for Gated Recurrent Unit, is a type of recurrent neural network designed to handle the sequential data with long-range dependency. It mitigates the vanishing gradient problem, analyze the historical wind speed data and relevant features to learn the temporal pattern that influence the future wind speed. And the next one is CNN. It stands for Convolutional Neural Network, is a deep learning architecture mainly used for the image recognition, also be adopted for the sequential data by treating it as images in the specific format. In this project, CNN processes the time series wind speed data as of the image, extracting the spatial pattern that contribute to the predicting wind speed. And the next one is CNN 1D plus CNN 1D. It likely refers to the combination of two 1D convolutional neural network where each network processes the data independently and the outputs are combined. In this setup can capture the different level of temporal pattern and enhance the model capability to learn the complex relationship. And the next one is CNN plus GRU. This model combines the convolutional neural network and the gated recurrent unit, merging the spatial and the sequential analysis. In the wind speed prediction, it leverages both the spatial and the temporal pattern to improve the prediction accuracy. The CNN extracts the spatial feature which are then fed to the GRU to capture the temporal dependency, resulting in more accurate prediction. And the next one is LSTM autoencoder. An LSTM autoencoder uses the LSTM layer to create an unsupervised model that learns to compress the input sequence and then reconstruct them. In this project, it be used for anomaly detection and the wind speed data, learning the normal pattern and identifying the deviation. And the next one is of CNN plus LSTM. This model combines the convolutional neural network with the long short-term memory, using both the spatial and the temporal analysis. For the wind speed prediction, it captures both the spatial pattern and the temporal dependency in the data. It captures the spatial feature where then processed by LSTM to learn the sequential relationship between them. And the next step is user gives the input. Here we used the Flask web framework to create an application where the user provides the input related to the parameter that influence the wind speed prediction. And the next one is the given input is pre-processed for prediction. The user provided input is pre-processed to ensure the compatibility with the trained wind speed prediction model. And the next one is trained model is used for the prediction. The pre-processed user input is fed into the trained model to predict the wind speed, where each model processes the input and provide the wind speed prediction. And the next one is final outcome as displayed. The prediction from the different models are aggregated and presented as a final wind speed prediction with the help of Flask as a web framework. And the execution of the project, to execute the project first, we need to open the code folder. And this is the code folder containing of various files within it. The static folder containing of the CSS, fonts, images, JavaScript files within it. And the template folder containing of the home, index, result, sign-in and sign-up pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handles the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model is a SAV file which contains the algorithm information and is loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. And the notebook is an IPYNB file which contains the combination of code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appear to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda form. Here we need to write a command that is cd space and paste this code folder path. By this, it will change the current directory to the code folder path, and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the class framework will host the application locally. The address like this. We need to copy this address and paste it on any of the web browser. I prefer to use the Chrome. And pasting this link and then click on the enter button. Here it will redirect you to this page containing of some detail about it and the title of the project. Then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it redirect to the sign in page containing of the username and password that need to be filled, and then click on the login button. Here it will redirect it to this page containing of some input details that are need to be filled to predict the result. And here we need to enter those details as of the first indicator value is 23 and the perception amount is 3.5, and the second indicator value is 36 and the maximum temperature is of 18 degrees, and the third indicator value is 24 and the minimum temperature is of 13 degrees and the grass minimum temperature is 14 degrees. And then click on the predict button. Here it predicted the result as of the wind speed is minus 2.82 mph. In this way, we can predict the speed of the wind by using various deep learning algorithms. And in conclusion, the proposed probabilistic wind speed approach, which includes an ensemble residual neural network, an error-based loss function, and a modified kernel density estimator, shows a significant improvement in the accuracy and reliability compared to the several state-of-art deep and shallow networks. The proposed approach provides a comprehensive form of information about the wind speed, which is essential for the operation of the power systems.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.